Hey guys, Mr. Middleton here. Today we're looking at word problems. We're looking at consecutive integer problems specifically. At the end of this video, you should be able to rewrite a variable in terms of a second variable, and you should be able to set up word problems involving two variables. Let's say two or more variables. Okay. In the next few lessons, we'll be setting up and solving more advanced word problems. And so let's jump into our first example. So here we go. The sum of three consecutive integers is 147. Find the three integers. This problem is saying that there are three unknown numbers add to 147. Okay, we know add because it says sum. So therefore, the equation we can get from this is x plus y plus z equals 147. We don't know any of the numbers. We just know that three numbers add up to 147. Okay. However, we have no way of solving this because there are three variables. Okay, we know how to solve equations with one variable that we don't, or one variable, but with three, kind of difficult for us. So to fix this problem, we need to find a common link. Some kind of way that we can say, okay, these are how these numbers are related. That way we don't have to use so we don't have to use x, y, and z. So we need to find a common link between the variables so that we can rewrite each variable. In this case, we'll say y and z. We need to rewrite y and z in terms of another variable x in this case. Okay, so but what we're trying to do is we're going to try to find a way that we can say, well, instead of saying x plus y plus z, let's write this in a way that we only use one variable. And here's how we're going to do it in the case of consecutive integers. We don't know what these numbers are specifically, but we do know something about these numbers. We know that these numbers are consecutive. And I always like to think of, any consecutive numbers and try to see how it fits the situation. So I'm just going to come up with three random consecutive numbers. Let's say 14, 15, and 16. Okay. They aren't the answer to this problem, but they're consecutive numbers. Alright, so let's pretend, let's say, that x is 14 and y is 15 and z is 16. We would not be able to solve a problem if we wrote x, y, and z. Okay, we wouldn't be able to do it because, again, there's three variables. How can we set this up, though, so that we can solve it? Well, we're going to find this common link. We're going to find the common link between the numbers. And the common link in this situation is that they are consecutive. Consecutive means that they come right after one another. Okay, what's after 14? 15. What's after 15? 16. We know they come right after one another. So how can we write these numbers in a way that we can solve them? Well, since consecutive means comes right one after another, instead of writing this next one as y, we know that 15 is just 14 plus 1. And 16 is just 14 plus 2. So we can rewrite this, instead of saying x and y and z, we can say, well, this is x and x plus 1. And we can say x plus 1, but I'll just say x plus 2. And so now, even though we don't know any more than we knew before, we can actually set up an equation to solve this. Okay, so our new equation is going to be x, our first unknown number, x plus 1, our second unknown number, and x plus 2, our third unknown number, and that equals 147. Now I used the numbers 14, 15, and 16 here just to show you why it works out that way. But for all consecutive integer problems, when they say we just have consecutive integer problems, that's how we can set it up. We know that one number we don't know, but the next number is one more than that, and the next number is two more than the first number. Okay, and now we can simplify that. That gives us 3 x's plus 3 will equal 147. Just adding our like terms. 3x plus 3. Okay, and so now we can solve for x. So when we do solve for x, subtract 3 from both sides, it gives us 144. So 3x equals 144. Divide by 3, x will equal 48. So x equals 48. And that means that our three integers are 48, that's x plus 1, x plus 2. 48, 49, 50. And you can add those up to see if it works out for us. 48 plus 49 plus 50, 147. And so, fits our problem, solves our problem. Alright, you can try this next one on your own if you want to, or follow along with me. But it says the sum of three consecutive integers is 2,730. Find the integers. Okay, so here's our equation. Don't know the first one. I don't know the second one. And I don't know the third one. Number 1, number 2, number 3 equals 2,730. Okay, or 3x plus 3 equals 2,730. Alright, subtract 3 from both sides. 3x equals 2,727. Divide by 3, x will equal 909. Okay. And so, if I add those up again, 909 will be the first number. Plus 1 would be 910. And 109 plus 2 is 911. So 909 plus 910 plus 911. And there we go, 2,730. Solves our problem again. Alright, so on a test or quiz, I might ask you, you might see problems like this, similar to this, and now you know how to set them up. But remember that it's not going to be the same thing every time. You still have to make sure you read the problems. Just because you read consecutive integer doesn't mean that you know the whole process. So make sure you're careful in that still, as this next example shows. Here we see that the sum of four consecutive integers is 862. And they want us to find the largest integer. Okay, the largest of those four consecutive integers. So here we go. We have 4 consecutive integers this time. Important. So I have now x plus 1 plus x plus 2. So these are my 3 integers. Plus x plus 3. Now I have my 4 consecutive integers. Equals 862. Okay, so now add all these together. 1, 2, 3, 4 x's plus 1, 3, 6 equals 862. Alright, and so now I can find my value for x. So I have 4x plus 6 equals 862. That means 4x will equal 856 after I subtract 6 from both sides. And then divide by 4, and x will give us 214. So we find out that x is 214. That means the 4 integers are 214, 215, 216, 217. Plus 1 plus 2 plus 3. Okay, and so the answer that we should give to this problem isn't 214, even though that was x. Even though we found x to be 214, the answer is the largest integer, which is 217. Okay? Flipping to the back, some more complexities to these types of problems, just a little bit. Alright, the sum of 3 consecutive even integers is negative 72. Let's find the integers. So, let's write any 3 consecutive even integers on here. Let me see, I'll do 22, 24, 26. What do you notice? Well, now instead of increasing by 1, they increase by 2. Okay, so if the first even integer is x, what's the second even integer? Well, let's say this is 22 is x. This next one will be x plus 2. This next one will be x plus 2 or plus 4. Okay? And so now we can solve this problem. It's a little bit different, but we can solve this now. So I have x plus 2 plus x plus 4 equals negative 72. Okay, you can try to go forward and try to solve this if you want to, or you can follow along with me still. 3x plus 6 equals negative 72. I'm going to subtract 6 from both sides, and so I'm going to write this up here. 3x equals negative 78. Divide by 3, then x will equal negative 26. Okay, so what are the integers here? Well, negative 26 plus 2 will be negative 24, plus 2 will be negative 22. Oh, crazy. I did not do that on purpose. But one thing that I want you to notice is that these are negative numbers. Okay, so negative 26 plus 2 is negative 24, but most of the time students will write negative 28 and negative 30. Okay, you can help yourself out by checking your answers once you're done to see if it works out as you see that I've been doing. 26 plus 24 plus 22, make them all negative, negative 20, negative 72. Okay, or you can make sure that you're adding those numbers correctly. This is x, this should be x plus 2, negative 26 plus 2, negative 26 plus 4. Okay? Alright, this next one's kind of tricky because people continue to forget it, but we have to look at odd numbers. So the sum of 4 consecutive odd integers is 34. What is the largest integer? So let's talk about any negative consecutive integers. Is negative 37, or not negative, why am I doing that? 37, 39, 41. Okay, what do you notice? They also increase by 2 between each integer. Because it's odd, a lot of people want to say, instead of saying x plus 2, x plus 4 like you do with even numbers, a lot of people want to say x plus 1, x plus 3. But that will not work out. So they still only increase by 2. So the same way, if our first integer is x, our next one will be x plus 2. Our next one will be x plus 4. Our next one will be x plus 6. So even in odd integer problems are set up and solved the same way. Alright, so let's solve it. So we got 4 numbers that we add together, x plus 2, plus x plus 4, plus x plus 6. Okay, so those are all of our numbers, right? 1, 2, 3, 4. Equals 344. Add all our terms together, 1, 2, 3, 4 x's, 4x, 6 plus 12 equals 344. We can subtract 12 from both sides, so we have 4x equals 332. And that should give us 83. 83. So what's the answer to the question? Well, x equals 83. But they want to know the largest integer. Okay, so the answer to the question, 83, 85, 87, 89. The answer to the question is 89. And in this case, you won't say x equals 89 because x didn't. X equaled 83. But you will say the answer is 89. So, since consecutive even integers look the same as consecutive odd integers, what's the difference between them? The final number is the only difference. Okay, the final number is the only difference. So make sure that you still pay attention to that. When you're asked for consecutive even integers, your answer should be even. When you're asked for odd integers, your answer should be odd. Okay. Consecutive integers are not the only type of problems that require rewriting a variable in terms of another, but they do provide good practice with the skill. So below is another example when the skill is needed. Straighten this up just a little bit. Okay. So Roger cut a 200 centimeter board into two pieces. The larger piece was 5 centimeters more than double the shorter piece. What are the lengths of the two boards? Okay, so here we go. We know that Roger has a small piece and a large piece. If we said, okay, well, he has a smaller piece and a larger piece, and it equals 200 centimeters, would we be able to solve this? No, we wouldn't, because there's two variables. We can only solve equations with one variable in it. But if we looked at this and we said, okay, let's do what we did with consecutive integers and find out the common link between the two. Okay, this problem says that the larger piece is 5 centimeters more than double the shorter piece. We can write that. The larger piece is 5 centimeters more than double the shorter piece. And that helps us out, because now instead of saying S plus L, short piece plus long piece, we can say, well, the long piece is the same as 2 times the short piece plus 5. So we can say S plus 2S plus 5 equals 200. I should have wrote that on this line. So you write that on this line. Alright, and now this is an equation we can solve. We have 3S plus 5 equals 200. As we solve it, we have 3S equals 195, subtracting 5 from both sides. And then we divide by 3. And so then S equals 65. So the shorter piece is 65. And I can really revisit either one of these equations to find out what the long piece is. I'll plug it in here. So I have 2 times 65 plus 5. That's 130 plus 5 is 135. Alright, see, so relating one unknown to another unknown allows us to solve problems that we'd otherwise be unable to solve. Okay, so there we go. There you have it. Hopefully now you can solve consecutive integer problems, but more importantly, you can define a variable in terms of another to solve more advanced word problems. See ya.